lot of people. They have a co-working space. They do a lot of events. This is just one of the many, many events they have. So you can also follow them on their webpage, capitalfactory.com. They have a LinkedIn. They have a ton of events. All right, so like I said before, these are all the talks that we have had here in Austin and Houston, and we're gonna have at least 2 more for the end of the year in each city. And well, we are blue people. We don't sell tequila, and we don't we do software development. So we do custom apps, and we have offices in Mexico, here in the States, and a lot of clients here and in Mexico as well. And we hire people a lot from Latin America. So if you want more info, please follow our website or ask me at the end of the talk. We have a lot of social media. We have our Blue People LinkedIn, Tech and Tequila LinkedIn, so you can also follow us there to make sure that you know the next date and the topic about these events. All right, so today we have an awesome speaker. Is Antonio Rodriguez. He's been here in Austin for 24 years. He likes to invent things, and right now he's going to talk about AI in the Internet of Things. Before we start, I just wanted to let you know that during the talk, if you want a drink, just raise your hand, and Enrique is going to help us bring you a drink all the way to your place. Excellent. I'll bring one for you. All right, so please let's give Antonio a round of applause, and let's see what he has to share.
Well, thank you. Hello, Austin. Hello. Yeah, I like saying that. So let me just start with on my way here. I'm pretty sure I took a picture because we're going to be talking some things about this. Someone was asking me, okay, what's going to happen in a year? A lot of the things that we cannot even fathom happening are happening already, and we're going to be talking about that. This is Internet of Things. This is artificial intelligence. This is way too many sensors, and we're going to talk about that. But before, I'm going to play a quick video. I did this video, I showed it last year. I want you to remember that it's 1600. I don't sell them, by the way. So this is not an ad. And now I lost my presentation. It's somewhere here. I'll get there. Here we go. Okay, my name, I like saying this. My name is Antonio Rafael Rodriguez Chapa. I like saying it, keeping my heritage. First, a disclaimer, this is not a philosophical talk. I did take some slide out because I didn't want to put them there, but I'm going to talk about the current state and what I believe is the future state of technology, not on the moral side, nor anything, just as it is. First, and a lot of people get confused with it. What is IoT? IoT, it's all about connected world of machine. That's what it is. Another one that now that AI is in the news all the time, what is AI? What is machine learning? Well, AI is something that simulates natural intelligence, nothing more. What is machine learning? Something that learns. That's it, as easy as that. Now we go into some other ones. What is an agent? An agent is an autonomous, intelligent entity that interacts with the environment and has goals. We're going to talk about agents later. What is a swarm? A swarm, because a lot of people got confused with what just someone OpenAI published. A swarm is a decentralized, self-organizing agent. What are AI sensors? An AI sensor is a device that detects physical parameters with temperature, acceleration, an image, etc., that has internal AI. That's important, internal AI. It doesn't go out to find a pattern or whatever. It's internal in the sensor, it's built in the sensor. What is Industry 4.0, 5.0? 4.0, it's something that has been happening for a lot of time. It's almost a cliche, but it's automation through IoT and artificial intelligence of the things. What is 5.0? A lot of people say, oh, 5.0 is the one that it's going to bring us even more technology. The only thing that is new about the 5.0 is that humans are being taken into the context, and it has some other environmental things, but that's basically it. Now, this didn't start as a lot of people think, artificial intelligence started in 2022 when everyone started talking about it. No, this has been an evolution, and the same Internet of Things with the definition that it's a machine that is connected, started in the 70s with the ATM machines. What else started in the 70s? The first automation. Some of you, I certainly do remember the first home automation devices that, with a protocol that was called X10. Back then, it was already connected, not to the internet. It didn't exist, but it was connected. And in 2002, this I was thinking whether to place the Roomba or not into this presentation. I love the Roomba. It's the first intelligent device that everyone recognized. Why? Because under the definition of artificial intelligence, it's something that mimics intelligence. So it's at the same like the first worms that existed at the beginning of evolution, the first animal. The only thing that they did, and it was intelligent, it did have some neurons for that, it was go straight, it had certain sensors, and at a certain point is continuously deciding whether to turn left or right or keep straight. And that is the very definition of intelligence. Right? It's not IoT, but I love it. The first one that combined artificial intelligence and the Internet of Things was the Nest. Why? Because it was not only connected, but it had certain algorithm to detect your preferences about the temperature that you liked, about what hour, the temperature outside, etc., and learn from your preferences. So that's what was one of the very first commercial devices that combined both artificial intelligence and the Internet of Things. Now it's everywhere. Now you don't even know that it's around you. You have, I'll end up with this one, the Roomba. The Roomba, the same one that started on 2002, now it does scan and map a room. If it goes into something that shouldn't be in the room, it remembers, and it'll come back later to clean it. I already said that. It maps the room as it moves with a few sensors that it has, but it does it, etc. It's a really very interesting use of algorithms. Another one is the Hue lights. The Hue lights were one of the first that came into the Internet of Things. Back then was just Internet of Things. Now that it's interconnected, it can make intelligent decisions like is the sun down, is it sun up, etc., to make decisions. Alexa, Google, Siri is everywhere, and that's artificial intelligence, and that's the Internet of Things. So it's all around that. Now, finally, both, and this is very important, and I'll tell you why in a minute, both iOS and Android before that, now they have their artificial intelligence chips, if you will, to do inference. What does it mean? That it doesn't have to go to the cloud to make a decision about what you're doing. I don't know if you noticed, like when iPhone started doing face recognition. At the beginning, the training was kind of slow, and the reason was that whatever images it was taking of you, it had to go to the cloud, make a pattern of you, and then come back. Now it does that training inside. Now, for everyone that is familiar with artificial intelligence, we have training and we have inference. Inference, it's way lower computational cost. So most of the artificial intelligence Internet of Things devices, that's what they're doing. They're doing local inference. And the Nest has evolved quite a lot. So part of the important thing about the Internet of Things is that it's all connected. The very first protocol that started with the connection was the Zigbee. It was not the only one, but it was the one that was mostly used. If you've seen, even back then, you could see already that there was a synchronization within traffic lights, or the post, the light post will start illuminating or not illuminating. And it's really difficult that you have all the devices, all these intelligent devices connected to a central computer making a decision of what to do. So what it does is that in the connection, in the mesh connection, that's the one that is being used mostly on the Internet of Things. What happens is everyone is a router of messages. So let's say I'm a traffic light, or I'm a sensor, a water sensor, a water meter, and I want to send my stats of consumption to a central place. So I send my message to whoever is listening, that normally is another water meter, and that the next one, since it knows that it's not the repository of that message, so it gets routed later and later, or to the next and to the next and to the next, until it gets to the actual node that is the one that should receive the message. So most of the Internet of Things devices, especially the ones that are working at home, work that way. So that's the reason you have lights all throughout your home, because whenever you turn a light, the message to turn the light is not going to go necessarily to the light itself. It's going to go to all the devices that listen, and then it'll be transmitted until it gets to the light that was intended, and it'll be turned on or turned off or whatever. Zigbee was the first one. Started a lot with industrial, with government, cities, utilities. There was a standard that was formed about the same time, the 802.15.4. All happened around the 2000. There were another ones like Z-Wave that they were doing also home automation. Then it came Bluetooth mesh that was introduced by Bluetooth organization. Thread was mostly pushed by Google. So if you have a Nest device, it's using Thread as a communication protocol. Then it came Matter, where it was a mess. So everyone was doing their own protocol, and they used a gateway in order to go to someplace central and then go back to the other one. So until they all got together and they decided on Matter. Matter is a multi-physical medium. If you're familiar with the 5 and the Mac on the ISO, they use different, the 802.15.4 for Zigbee and for Thread, the Wi-Fi, the Bluetooth, and they came out in a way of everyone communicating with everyone. If you have, like for example, if you have an Apple device, most likely in your home, it's going to be a Matter hub. What does it mean? That it's going to be receiving signals from everyone that complies with Matter, and it'll use it to have your home automation. So Hue, Alexa, Google Home, HomeKit, SmartThing, they all decided to use this protocol, and all new TVs comply with this protocol. That's on the local stage, and that includes industry. On the global stage, one thing that became very popular for the Internet of Things was on LTE. There were 2 cat bands that were defined specifically for the Internet of Things. One of them is narrowband IoT, and the other one is LTE-M. So what is so great about these two is that they're really, really low power. So you can have a device that is somewhere lost where there's cellular reach, of course, but it can have a battery, and it can last between 5 to 10 years, because it only wakes up to, let's say it's measuring pressure of something. So it wakes up, it's already implemented to connect really quickly to the cellular network, and send whatever it's going to send. And by the way, you know this, cellular is also mesh. So originally, as I place here, it's all about mesh. Most of the protocols that are being used are mesh. So what are emerging concepts that are coming on IoT? AI in sensors. I'm going to show it later. It's most of all the inference being done at the sensor. Why is that important? First, you don't have to be connected. Second, decisions are taken in milliseconds, not the round trip to the cloud or to the computer or whatever edge device that there is. Edge computer. This is a term that everyone uses loosely. In the Internet of Things, what I like to think about an edge device, it's something similar to the Raspberry Pi. For me, that's an edge device. And there's a lot of similar ones, but if you don't have enough with your microcontroller, you can go to the edge device, make some computational things over there, and come back. Digital twins. Digital twins is the exact representation of how the cloud is making a mirror of everyone that is physical. So let's say you have 1,000 devices out there, physical devices. Digital twins means that you have you might call it, it's a digital representation of whatever is going on the physical device, but on the cloud. Why is that important? Because since you not necessarily can interact with the physical devices all the time, if you have some applications on the cloud, you can interact with your digital twin, and that digital twin is going to take care of synchronize with the physical device. So that's and everyone has this, AWS, Google, Azure, etc. Agents. Agents is a device that perceives its environment and has goals, like self-driving cars and drones. So I'll leave it at that. You've heard about LLMs all the time. Maybe you haven't heard, or maybe you have, about SLM, small language models. It's what's been getting popular to put NLP on small devices. And by small, I'm talking Raspberry and up. So we're not talking about microcontrollers. But it's a way of having natural language processing on devices like, I don't know if you saw the dog that was talking to the human. It's strange to say talking to the human. But it's because it has an NLP machine inside. Now, maybe for that demo, it was connected to OpenAI or whatever at that time. But the thing, when you make it local and there's a very new small footprint language models now, like the Llama 3.2, that you can implement with a little computational power. And finally, Swarm. Swarm is physical agents performing collectively. So you know about agents, that have goals, etc. Swarms are agents that have a common goal. So I'll start with one of the one that I like the most. I love everything about vision because it's the one that gives us more indication for things that are useful for the Internet of Things. It's very hard to up to now to implement CNN for those of you that know about artificial intelligence. The typical way of detecting or classifying images is through CNNs. And I'm not talking about the radio station or the TV station. CNN is very computational heavy for any microcontroller. So what happened was that the one that I follow, because there's some other one, like before the pandemic, I knew that from Honeywell Labs that they were working on this as well. It's inference. If you remember, in artificial intelligence, inference is the lighter part of artificial or machine learning. I'm going to stop saying artificial intelligence. Or machine learning, the lighter part, it's inference. The harder part, it's the training. So imagine you want to do box classification. So what you do is you train a model that is going to be detecting boxes, and then you get that model, the result, using something like TensorFlow Lite, and then you download it over here. Look at the finger. You download it over here, and over here the inference is going to be done about detecting boxes. Now, why is that important? Because let's say you have a line that is very rapidly passing boxes and you want to count them. But so you don't have time for every picture that is being taken on a stream of pictures, which is a video, to go up to the cloud, make an inference whether it's a box or not, and then come back with a resolution where we're talking at least half a second there. So this would be milliseconds. So speed matters. Arduca, and this used to be something that you could only get if you were doing like hundreds of thousands of dollars in research or whatever you're doing for your proof of concept. But now Arducam, which and others, but Arducam is the one that I know. They came with a camera that has a Raspberry Pi inside, and it has this, the sensor as a sensor, and it's doing whatever inference you made a model for in order to detect that. How many of you know what an image sensor is? Shoot, I lost you. Okay. Okay, I'll go back a little. Whenever you have a camera, the lens is not the important part. It's the one that is taking the image, etc. But at the very end, you have an image sensor that it looks like this. That is a matrix of a CMOS sensor, most likely, that are going to be detecting each of the pixels of the image that is being taken. And this is universal. Every camera that you have, it's going to have one of these. Some bigger, some slower. And in this little part, it has like a very, very small microcontroller that is called the ISP. And it's the one controlling the scanning, the illumination. Maybe it's going to be doing also the compression to turn it into a JPEG, and the transmission is going to be JPEG, etc., etc. But the fact is, it has a sensor, an image sensor. It detects light. It has an ISP that is like their local microcontroller. Look at the size of the finger. And inside this, just imagine that, inside this, TensorFlow Lite is running. So, at least for me, that's mind-blowing. Okay, so what does this mean? This means that, as I was saying, you can count really quickly. We're not talking about a camera, a very specialized camera that is going to be connected to a server in the cloud doing the inference of counting boxes. No, it's going to be local over there. Defining, since it does classification, you can train a model about the different stages of ripeness of a tomato. Then you have a drone or a person just going with a personal camera or a Raspberry Pi. This is a Raspberry Pi, and I'll tell you something about it later. That is designing, I don't know if you saw this, it's deciding the ripeness of the tomato for whatever reasons you have. Oops. It was working before. Okay. But I went one after. Okay, it also means that for Industry 5.0, I was saying that is the interaction between this IoT, either robots, processes, machinery, whatever it's happening with human. So, but how do you do that? To begin with, you have to classify what's out there. So you have a classifier that is telling you whether it is persons, it classifies its person, or boxes or clocks or whatever. Something has to do the classification in order to understand what the next steps of whatever is going to happen is going to be. It has to be something that really understands what's going on the industry floor, on the manufacturing floor. Let me see if I can go back to this being nice. No, I lost it. Okay. Okay, so what are some of the nice things about this? This little computer, it's $100, and it can perform AI. Even better yet, there's a new coprocessor on top of it that is called. They came with something that is called HAT on Raspberry Pi, in which you can add certain other processors. And this little chip, it's an artificial intelligence chip. What does it mean? It means that whatever you're doing, let's say you have you need to do local training, or you need to do local inference because you're doing something that goes beyond the sensor's capability of doing inference. Well, you can do it on the edge. Again, you don't have to go to the cloud. You can do it over here. This hat, it's $70. So what does it mean? It means that anyone can start doing their own experiment, their own proof of concepts, etc., for whatever they want to achieve. It's not the $100,000 plus experiment. So it's artificial intelligence in the Internet of Things is something that you can do in your own home. And of course, there's everything about the camera, since now computationally they take way less demands. You can have several. This is an example in which you can connect up to 8 cameras to a single Raspberry Pi. So why would I do that? Oh, maybe you are doing a multi-sensor. There's a discussion in the industry right now whether vision is better than LiDAR or vice versa for mapping the external world. If you're going to do it through cameras, you can use this. I really lost this. No, I'll continue with this. So, agents in IoT. I was saying agents are machines that have a connection with the environment, or they're sensing the environment, and they have goals. So let's say you take you take a Waymo. You tell it where you're going. That's the goal. So the self-driving car is going to decide how to go there, but you're giving it a goal, and it's going to be sensing all the time whether there's person, dogs, cars, bicycles, etc. It makes all the decision in order to achieve the goal. What are some other ones that have goals? The drone industry is like really booming in the different areas. One of them in agriculture. In agriculture, you can sense quite a lot of things. If you remember, I showed you how you can detect the ripeness of a tomato. So the same way, you can detect whatever you want, and you do it just going through the field. All of them are interconnected. This can be the one that is taking the aerial pictures of the whole field. This can be the one that are taking instructions of how to distribute things, etc., etc. So that's what an agent in artificial intelligence of things would do. And now the robots. Everyone loves the robots. I certainly love the robots. I showed you one, which I told you the most special thing that I liked about that robot was not that was the most advanced, although it looks quite advanced. It was the fact that you can get it for $1,600. This same company, it's coming with another robot. I guess they're competing with Tesla. I'm going to jump quickly between different things. No, I don't like that one. My anthropomorphizing part hates that. This was just marketing, because we now know that if you have an LLM, you can do that. So it's not that difficult to implement that in a robot. A lot of people said, "Oh, they're being handled from someone else because I saw the hands, whatever." My opinion is that that's with the stage of things, not that I could do it, but with the stage of things, it's not hard to orchestrate that. And talking about swarms, those are the same dogs that I showed you earlier. Okay. Okay, this is the part that I hate about placing videos. Okay, so what's next? Well, for one thing, a merge feature. This was about 2 years ago. I don't know if you read about it. It's scientists in Australia in a university grew some neural cells. They placed some interfaces and they train it to play ping pong. Doing something that the brain does that is called active inference. And it was playing ping pong, the typical one that you've seen, that it's a ball that is being bounced by a slider that you slide. So the brain was doing the slider. It learned in 5 minutes. Now that's not a great achievement, but what's more important is that there's a future coming in which the brains could be natural brains or grown brains, if you will. Remember, I started with not a philosophical talk. The brain has 200 million years of evolution. So we're not even scrapping the surface of everything that a brain can do. We're emulating a neuron, and we're placing several neurons in something that is called the perceptron that was invented on the 50s. When I like to emphasize this, I say last millennium. So we're not even scratching the surface of what a brain can do. Even if we're thinking that, oh wow, this is the most important thing, we already got there, we're about to get artificial general intelligence. No, we're not even there yet. A brain consumes 20 watts. An LLM like OpenAI or any of the other ones, we're talking tens of megawatts. So there's quite a difference. It has an impressive intelligence and everything, but if you're talking about power consumption, we have a long way to go. The brain does continuous learning. I don't know if you know what GPT means. GPT is a generative pre-program GPT transformer. I haven't said it in a while, so I had to remember. So why is it called pre-train? Because you have to train it every time. And you say, well, but what happened with everything that is being added continuously, etc., etc.? Those are like layers, and they're called guardrails also, that they build on top of what is called the foundation model. So you have layers for simulating continuous learning, but in reality, it's pre-trained. Our brain, it learns continuously. I'm learning about you right now, and I don't have to do my training of my brain from scratch again. So we have integration with the world. If you try to do 3D things with ChatGPT, well, they've been playing tricks in order to have more spatial abilities, but we know naturally of the world because we live on a 3D world. We know about us. We know about us in our place in the world. We know how to move. We know how to sense. We know everything. Since we're babies, we start kicking, trying to understand our body, to understand our limbs, to understand everything. We don't have that. Any robot that you can see that they're saying that is close to a human, no, way off. Curiously enough, the thing that we're most proud of, intelligence, that was the easiest thing to copy. We will see increased natural integration. We talk about Industry 5.0. So Industry 5.0 is integrating all this into the human environment, so the robot do not move when humans are working. They take care of understanding where people, objects, dogs, cat, whatever are around in order to interact and do their common goals. So Gerardo was telling me about some new framework in which this human interaction is being taken into account now on the design issues for processes. So this is coming more and more. I already gave you my opinion about, and it's just an opinion, about narrow versus general AI. And finally, one thing, the most important one, everyone is making AI processors. Amazon is doing it, Google already did it, Microsoft is doing it. It's not only NVIDIA. So you have a huge array like the one I showed you for Raspberry Pi to make the computational task for neural networks, which is different from the one that we're used to. Way easier, using lower power, and finally making decisions easier. Thank you. Question over there.
What do you think are the key abilities, knowledge we should all be trying to develop as technology is evolving so fast? What are some things we have to stay on top of?
For like being on the technology area?
Yes.
Well, everything changed. There's a saying that I've seen in some memes that says, good news, artificial intelligence will not take your job. Bad news, someone with knowledge in artificial intelligence will take your job. So there's quite a lot of new skills. The very first thing is knowledge about data. Everything is about the data. It's no longer knowing how to program and that's it. Now you need to know about the data. You need to know what it represents, how are you going to handle it, normalizing, etc. How are you going to train your models? What you're looking for now. For everyone that hated statistics or probability when they were studying, I have bad news for you. It's all about that now. All of it. Everything is prediction, everything is sensitivity, everything it's about handling true and false positives and negatives, because you have to know your end result. If you cannot measure that level of precision that under new circumstances is never going to be 100%, otherwise it's overfitted, you have to learn about that. So yeah, the field completely changed.
More of a capacity question, but you touched on the new capability of having asynchronous on the devices themselves. And one of the questions that I hear in the industry is the cloud capacity and the limitations thereof. Given the local devices that are increasing the capability to do AI, do you think that's going to accelerate the demand for cloud capacity, slow it down? Who knows?
Well, there was a friend that told me, I have NVIDIA, should I sell it right now? Or I think it's going to be parallel things. For one thing, there's quite a lot of more demands of new things, like the new swarm that OpenAI, an engineer in OpenAI came up about. It's about agents. So you're going to have a lot of agents demanding the API. In my book, that's still not a swarm. Swarm is when you're independent, but I read the framework, and the framework includes being independent with other LLMs like Llama and intercommunicating between the agents. So on one part, there's going to be a growth on that. On the other part, a lot of the computational power is being offloaded to the sensor or to the edge device or whatever edge device you have. So if the only thing you want to do is recognize a command and act accordingly, you don't need a whole lot of intelligence for that. You only need to have a preset set of recognized parameter that your model, your SLM is going to recognize and execute locally. So that's going to be an offload of cloud needs. Now, which one will grow quicker, the need of the cloud or the offload of the new frameworks? I don't know. But certainly there's going to be quite a lot of offload with things like what I showed you.
And just to complement with your explanation, one thing that came to mind is the healthcare sector and how you have all this, the general doctors, the specialists, and all of a sudden we had also the physician assistants or PAs. I'm not sure about using the term well, which is almost like a doctor, doesn't have quite all of the skill sets, but can handle a lot of the issues that a doctor normally would waste, quote unquote, his bandwidth on. So it's an advanced triage system because we're working in a system that is capacitated, where the demand exceeds the supply. And some of the things that you've touched on make me think that we're approaching or entering a stage in AI where we're also becoming more smart smart about how do we triage the different use cases, given the different shapes that AI can manifest. Does that make sense?
Oh, certainly. I have several friends that are medical doctors, and they hate me when I start talking, because whenever you, the same way that we started about intelligence on an LLM, and we're not talking about the first LLMs, we were talking about the current ones. That some of them in certain areas that have a PhD knowledge of things. Whenever you're doing surgery, a model will have way more training than any human doctor about the different manifestations that could happen in a body in a surgery. And I laughed aloud when this guy, the Turkish guy that did was the gold winner of a pistol competition, that it says, hey Elon, you think your robot could do this with a hand on your pocket? And it was an easy one. Elon answered, a robot will shoot on the bullseye every time. If there's something robot have had for a while, it's precision. So what are we going to need a lot in the future? And that's my opinion. Everyone that works directly with a human. You were talking about nurses. In my opinion, nurses are going to be irreplaceable for a while, because there's robots are way years behind in their ability to have the mobility, the sensitivity, etc., that we as humans have. So everything that has to do with knowledge, and just the knowledge, or precise movements, I think it will be an increased place where you will find robots or something similar to robots. Everything that has to do with the direct interaction with babies, with human nurses, etc., it's still going to be humans. Everything that has to do with us as a human race, I think will still be human, like lawyers, like elected officials, etc. We're not going to elect a robot, but that's kind of my opinion of where things are going.
And because I didn't want to drag us into a philosophical realm, the simpler version, I saw the physician assistant as your smart devices, and then you have the doctors, especially if they're specialists, as your underlying models that are in the cloud. So it's these parallels of how in the healthcare setting there's this concept of triage and identifying the issue and using the resource that is most cost efficient. And that mindset is what I think we are starting to apply when we think about AI. I'm not talking about the interaction of human and technology. I'm talking about that mindset of adapting, of not using a shotgun to do a small cut or something like that. All right.
No, and you're right. There's quite a lot of needs of medical assistance in places like Africa, in which a lot of this automation is very useful. My my opinion is only an opinion in a sense that legally you need a doctor. The whole legal aspect, it's just another thing. So I'm just highlighting the fact that the final interaction with humans, I think, if most of all, if you're ill or something, or you're a baby, will still need to be humans.
Thank you.
Awesome. Let's give Antonio a round of applause, please.
My pleasure.
All right, so we're gonna hang out for a couple of minutes more, or yeah, we have time. So if you want drinks, we're gonna be there, or if you want to continue networking, please feel free to stay. And also, I think that Antonio would love to answer a couple of questions more if you have. I don't know if you're gonna hang out. Excellent. So feel free to reach him out and connect with him. Thank you all for coming, and cheers.